Do you remember the square root of 9? I hope so. Last year you worked on simplifying these. The square root of 9 is actually 3. What about the square root of 4? I hope you know that that answer is also 2. And the square root of 1 is 1. Now the reason that you know the square root of 9, the square root of 4, and the square root of 1 is because those numbers are considered perfect squares. What about the square root of -1? You may have had a teacher in the past tell you that it's not possible to square root negative numbers. I'm here to tell you that it actually is possible. It's just that it takes some numbers that we actually haven't learned about yet. So I'm going to introduce you to those right now. And they are called imaginary numbers. The square root of -1 is equal to I standing for imaginary. The numbers that you've learned about so far can all be seen on the number line in front of a classroom. Notice you have negative whole numbers, positive whole numbers, 0. There are numbers in between them like 1/2, right? All those fractions. Those have all been considered real numbers. 1, 2, 10. Those are considered counting numbers. If you want to consider the number 0 along with the positive whole numbers, right, then we'd call that set the whole numbers. When we introduce numbers like -2 and -5, now this entire set of numbers is called the integers, right? So integers are negative and positive whole numbers. Then we can add in fractions like 1/2, -7/10, 5/7. Now if we look at this entire group of numbers, right, including the whole numbers, we have rational numbers. Rational numbers are numbers that can be written as a fraction. Notice that the number 10 could still be written as a fraction, 10/1. Then we have numbers like pi and √3. Those are considered the irrational numbers. Notice that there's no overlap between the rational numbers and the irrational numbers. Together, the set of rational numbers and irrational numbers are called the set of real numbers. So all the numbers you've studied before are considered real. I am now introducing a number that is not real, the square root of -1, which I just called I. That's an imaginary number. But I could also do a combination of a real number, like 5, and an imaginary number like 2i. That's an entirely new number as well. We call those the set of complex numbers. I'll talk more about this in class, but notice that everything is now encompassed in a complex number set. Back to our real number line. If this only has real numbers, where do imaginary numbers go? We're going to create our own imaginary number line. It's going to be vertical through the number 0. We'll put numbers like I, 2i above 0, and numbers like -i and -2i below 0. Notice that now I not only have a number line here horizontally and a number line vertically, I also have space in between these two lines. Okay, and I'm going to switch over to my iPad and show you more about those in a second. So we have our real number line and we have an imaginary number line. We don't have a number line anymore. What we have is the complex number plane. Let's play more with that.
Before we graph some of these imaginary or complex numbers, let's just try some simplification problems. What about the square root of -4? Well, you might remember that the square root of 4 is 2. And we know that the square root of -1 is I. So in this case, we would say that the square root of -4 is 2I. We would do the same thing with the square root of -9. The square root of +9 is 3, and the square root of -1 is I. So here our answer would be 3I. What about a number that's not a perfect square, like 7? Whenever we take the square root of a negative number that we're not sure what the answer is, at least we can say that we know it's imaginary. I'm going to say that this is the same as I root 7. Next, let's see where these numbers are on the complex number plane. What if I were to graph the number 3 plus 2I? And let's label that point A. 3 is the real number, so I would go to, let's see, 1, 2, 3 on the real. The 2I is the imaginary part, so I would go from 3 and then up 2 spaces to right here, and that would represent the point 3 plus 2I. Let's try graphing another point, -1 minus 4I. The real component is -1, the imaginary component is -4I. So I'm going to go left 1 and down 1, 2, 3, 4. And that would be my point B. Let's try one more. What about the number 3I? So it just has an imaginary component. Well, 3I would be 1, 2, 3 up. So that would be my third point. Let's try some more examples on our own now.